So yeah, 2 speakers from each of the winning teams. From Team Kairos, we have Vinicius Goex and Nick Wojtowicz, if I pronounced that right. Sorry, Nick, if I didn't. From Team Obsidian, we have Edmund Mills and Dave Garg. And from Team NeurIPS, we have Tom Lieberman and Chan Jun Sharon. So yeah, so let's get straight into it. I'll just ask some questions and then I think you guys can answer it in whatever order you want. You obviously don't have to answer everything. But yeah, first question. I know Vinicius has already answered this a bit in his presentation. But what sort of generic piece of advice would you give to future participants in the MineRL BASALT competition?
I can reiterate that if you want.
Sure, why not?
Well, yeah, let me talk a little bit about it. Yeah, it's like, it really took us a long time to just understand the whole package, like how to work with Minecraft. At least for us, it was our first time. Like really understand the action space, the observation space, how to train the baselines, how to train the whole code, and do like an end-to-end submission with just like a random agent or something. So that took us like a good month to get really familiar to it. So maybe if you're thinking, okay, I really like this competition and I want to join it next year, maybe spend some time now. Just play with the package will save you some time for next year.
Yeah, I could speak next. I think one piece of advice I would give is to really figure out good ways to get feedback from the experiments you run. This was one of the big challenges was we could try different hyperparameters, different approaches. But if we were just looking at little clips from the evaluation episodes, it was hard to tell if anything was changing. So toward the end, we started playing around with some of the MineRL environments that gave rewards, like the navigate and tree chop environment. And I think it was helpful. I think it would have been helpful to start with that earlier. Or come up with some kind of rubric for evaluation episodes to try to get some kind of quantitative evaluation.
Yeah, so I take it with tree chop, you were just like using your method on tree chop while ignoring its rewards and then using the reward as a way to check how well you were doing.
Right.
Yeah, makes sense.
It's a pretty good idea.
Yeah, I can only second that. Maybe for me, I think it cannot be emphasized enough that you should really get to know the data set you're working with. So really look at the episodes. So for example, it could take the form of building some kind of viewer or looking at summary stats of the different observations or like actions and how it's like developing over time. Yeah, just to really get a feeling of what's going on. And then I guess that also translates or transfers over to trying to figure out what's happening with your agent.
Yeah, and it's also kind of interesting that our data sets are actually pretty small. I think I personally spot checked like 20% of the entire demonstration data set that we gave for BASALT, and it didn't take that long. It was a few hours. So you can just watch all of the demonstrations that your agent is going to be trained on if you so wish. But yeah, thanks. Any other answers, things to say?
Just say that's it's a good point to really go through the data set. But the problem is like, I feel like as machine learning researchers, we're always hesitant on wanting to do that. It's like, we don't want to do that. And even for us, like, we, tasked ourselves with providing some, these labels, but we always would put it off and sometimes find ourselves trying to, we'd rather spin and design new methods so we don't have to label as, do any of that manually labeling. But it's a good point.
Yeah. Actually, I am kind of curious. I didn't get to ask this before, but well, you collected like what was it, 80 something thousand labels for your submission?
82,000.
So
Yeah.
it sounds like a lot, but I mean, we did it split across our team. And what we did was we kind of like designed the interface to easily label. So we're not just like showing one label and you're pressing a button. You're kind of like, you know, holding down a key or two and it's like progressing through the trajectory. And you can like, you know, if most of the trajectory doesn't have anything in it, you're just holding down this button that's just saying like, there's nothing in this image and it's, you know, progressing.
Ah,
You could, you know, so we kind of like did tricks like that to make the labeling interface as quick as possible. And you can go through the trajectory in a small amount of time.
got it. So this 80,000 labels was probably like something like 10 hours of human time.
Yeah.
Probably
but
less.
nothing-
Yeah.
Yeah, nothing too, yeah, I would say less than that, but nothing too extreme. Not the most accurate labeling, maybe because our labeling interface was designed to be quick. So, but we figured like more labels, even if some of them, if we lose a little bit of accuracy, it's still fine.
Cool.
If I may ask, what did you use for your interface?
It was just OpenCV. So an OpenCV should display the image, then a black box around it and the buttons. And then OpenCV has some callbacks that it can read your keyboard and your mouse click. So that's what we used. And then we were just saving everything to disk.
Okay, thanks.
Really custom made for that.
Cool. Yeah. Dave or June, any thoughts? Or I can move on to another question.
I think most of the points have been covered. I would say. Yeah.
Yeah, I would say this was a very interesting environment because like normally when you're like trading on like some sort of RL thing, you don't really care about exploration that much. Like if you have some Hopper or whatever environments. But I think in this case, it's like a very randomly generated open world. And when you're trying to do some sort of imitation on this like random generated scenarios, it just feels like a very complex thing. So I think it's very interesting. I feel like maybe exploration is something I think that maybe needs to be taken into account more to solve such environments. So I think it might also make sense to look in some sort of, I don't know, curiosity-based learning, other methods as a way of getting more familiar with environments.
Cool. All right, thanks.
If I could add one thing on the lessons learned, was the, you know, for us, I think we could have spent better time using the submission pipeline maybe a little bit more frequently. Often, a lot of time we would democratize our, you know, project. We'd all work on different sections and we test it on our local machines and maybe we would put it together, but we very rarely submitted it, right? And so like when we had a full agent working together and then we tried to put it in the submission pipeline, we had ran into so many errors and a lot of that happened right at the last minute. We were kind of scrambling to debug all of these issues that we've never seen before. So yeah, that's definitely
The server crashed, I think, the last day.
Yeah.
We were up at like 5 a.m. whatever. Yeah.
Yeah, sorry about that.
That's okay.
Minecraft is not it's not a very forgiving technical environment. Yep. Anyway, I think let me move on to the next question. So what was most surprising about working on BASALT? Like if you met like through the however many months it was, 4 months of working on it, what thing did you least expect about working on this competition?
So I think at least for me, that was the first time working with an agent that would solve a task with those really long time horizons. And I mean, I've played like in the past with hierarchical algorithms and everything, but not even in the scale of Minecraft. So what surprised me the most is, you know, after seeing all the presentations, is that people actually got decent results. So that actually surprised me, which I thought would be really impossible when I first read the description of the task.
Yeah, I've gotten the same reaction from others as well. Other answers? Surely you didn't just work on this and everything turned out exactly the way that you planned. Maybe I'm just a bad researcher. Maybe everyone else's research just goes perfectly always.
I think maybe as a counterpoint, I did not expect the two easier environments to be that hard and pernicious in the beginning. Like I expected it to fall relatively quickly, and that turned out not to be the case. And even our final model, I don't know, has like a success rate of, I don't know, 10% or less or something.
Yeah.
Okay.
Yeah, same. I think for us, we expected, oh, the find cave, that should be the easiest. So we start with that one, and we spend a lot of time, especially since it's harder, and months go by and we haven't even started the other task, because the find cave is taking up all our time. But yeah.
Yeah, getting to human level performance on these tasks seems like it will be a challenge. I remember there was this one demonstration on waterfall where the demonstrator just like jumped off a cliff in order to throw a snowball midway down to get the perfect shot of a waterfall. I'm just
With
like,
style.
yeah, exactly. I'm just like, this is never, our agents are definitely not going to do anything like that.
So it's an interesting point, because like we noticed on some of the demonstrations, some of the people that made the demonstrations, they weren't that good. Like we have the assumption that, oh, all these human demonstrations, they're at an expert level, but that's actually not true. If the person providing the demonstration, let's say, is new to gaming in general or new to Minecraft, they can do the task, but they're probably not doing it that well, or maybe they're taking a very long time to build the waterfall, right? Or they're very, very slow at it, right? That's one thing we noticed for sure.
Yeah. Huh, that didn't match my impression, but I might have forgotten.
Well, I just remember there, one of our teammates, David Watkins, either him or his family member, they're like really actual big into Minecraft, like in playing the game.
Yeah.
There's a lot of speed competitions, and so there's people are really, really, really highly skilled at it, and they play it a lot. And from that perspective, when they look at these human demonstrations, they're like, okay, these are definitely maybe not the best, right?
Yeah, they're definitely not the best. There are definitely people who play Minecraft better than the demonstrators.
There's a mention from David in the chat saying that some demonstrations also didn't complete the task at all.
Yeah, there were a couple. If you know of any more that haven't been removed from the data set at this point, David, please just let me know and I'll make sure to remove them. I spot checked, I think it was around 20% of them, and all of those did in fact complete the task. And there were like a couple where the person like looked at the waterfall, then looked away, and then threw the snowball, which arguably maybe is not completing the task. But I think that was the biggest mistake I had seen. But then other people did point out some cases where, especially in Find Cave, where the human demonstrator just failed to find the cave. Yeah, other surprising things about the competition. By the way, viewers, feel free to suggest questions for me to ask all of these panelists. I'd love to get some audience questions.
I have a question to the panelists.
Great, let's hear it.
So it might be very like technical, nitty-picky, but or maybe it was just my ignorance, but we didn't have access to the scripts that recorded the demonstrations, right? Or we did have, or we did not have access, right?
That's right, yeah.
Yeah, so one thing that I noticed, so I worked a lot with computer vision in the past, and then like each camera is really different, like all the CMOS sensor and everything. So when you record data with a certain camera, let's say you train a classifier, and you deploy on a different camera, it might not work, just not because your model is wrong or anything like that, but maybe just the images are different. And one thing that I noticed, like from the videos that we receive, is that maybe the images were compressed with like a JPEG compression or something, just to reduce the size. but I think there was some loss of information there, because when I was generating the videos directly from the environment, I was saving like PNGs with like a lossless PNG, and my videos look different. So I just always had this in my mind, if that could cause a difference. Let's say if you just learn from the demonstrations, the image that you're seeing might be a bit more noisy than the ones that you actually see when you're deploying your agent. I was never able to confirm that, but I always had that in my mind. I just want to ask other people if they had the same thinking or not.
So I actually can answer that one, which is yes, there is a difference. We mentioned it on the AI crowd competition webpage, actually.
Okay.
I don't remember the details anymore because like we did this investigation in March, but like there's like one version of downsampling which is done internally to Minecraft and a different version that is done by a rendering pipeline, and for complicated reasons it was hard to make them all work
Yeah.
out. We like did an analysis and we're like, oh yeah, there just are quite a few pixel differences. Please be aware of this. So it's there in the webpage if you want to look for the details. Yeah, no worries. It was a long webpage.
Should have had some noise to our models.
It's just built-in data augmentation. What are you complaining about?
Yeah, exactly. Exactly. No, that's actually the best solution, honestly.
I think this actually was I think one of the pitfalls that I was worried about when we were training the preference model or the reward model to predict like which clips were like preferred, and then we were saying like, okay, all of the ones from the human demonstrations were preferred and all the ones generated by the model are less preferred. So there was one point, I think, when we first trained it, like we got like immediately like almost 100% like accuracy, and I did suspect that it was related to like because of the different like source of video for these two sets of clips.
It's possible.
Yeah, so that's one of the things that I think we would need to be careful about.
Oh yeah, that does seem problematic.
Yeah, like in theory, if you add noise to your models, to your source image from Minecraft, you could more or less mitigate that. But maybe, yeah, I mean, that's one solution. Like I said, I didn't have time to try, but yeah.
But wouldn't you then have to exactly match the type of noise? That's
yeah, exactly.
You have to.
I think like if you're worrying about like compression effects, then it'll be a different kind of like. Yeah.
You have to compress your own image just so they match. Yeah. But I mean, it's hard because like, how are you gonna record a large data set if you don't compress the data, right? So I think there's a trade-off right there, right? Otherwise you end with 2 terabytes of Minecraft data, right? Which could be also.
Is there a way though, like you can do like how they do on StarCraft, where can we have a human demonstration just be a series of actions, and if you're matching the same starting conditions, then you can recover
like game states. Yeah.
And then you just now you have actions which are very tiny, and you can.
But that makes it slower. So currently, if you want to train offline, then you can just load the demonstration data and train in huge batches if you want to. But if you would have to basically feed in the actions into the simulator to recover the game state, then that would make everything much slower.
So
no, I mean, you just like do it once, and then you can like then do your own image processing versus having the organizers provide all the images in the format, right?
Yeah. So the actual reason we didn't do this is that Minecraft is not a game that is meant to be modded, really. People do it anyway, but it turns out that there are like hundreds of different places where there's randomness in Minecraft, and you have to go and set each of their seeds individually to actually guarantee deterministic replay. And I think the MineRL project in general would love it if someone went and actually did this such that they could then do deterministic replays. But so far, no one has actually had the time to go and do it. And so you can't actually just save actions. So like what'll happen is you'll like save, the agent is like punching down a tree, or the human punches down a tree. the block flies straight to the human, and so they pick up the log and then they go make a crafting table or whatever. But then when you replay the exact same actions this time, the log flies away from the human. They don't pick it up, and then they like turn around and leave, pretending that they picked it up, try to make a crafting table, it fails, and then all the actions no longer make any sense.
Yeah,
Yep. It is, yeah. The Minecraft simulator imposes lots of restrictions on what things you can and cannot do.
I would say one of the surprising things that I've seen, this I only saw once, maybe 2 times in watching and rolling out our agent. We saw one time a zombie come out of nowhere and attack our agent. I didn't even know that.
That was not in the demonstrations.
Yeah, it is a bit surprising because it's supposed to be daytime for I think all but the village task. The horizon is long enough that it actually turns night.
In general, but I mean, it's definitely a good, good adversarial perturbation that our agent had to deal with. I think it had a pickaxe in its hand and might have just been randomly using it, and so it might have defended itself.
Oh wow, accidental destruction of zombies, amazing.
Talking about the issues of the Minecraft simulator, have you considered switching to something like Crafter, which is like a bit lower on the difficulty scale than Minecraft itself?
Oh, this is the like 2D grid world?
Yeah.
Okay, just give me a second. I've watched the video. I'm trying to remember how it works. Yeah, okay. I think the big issue there is that like I wouldn't expect to be able to design tasks that I didn't think you could just easily hard-code a reward function for. I'd have to look again at the environment to be sure. I spent like 5 minutes watching their clip, so I don't know exactly what the environment does. But it does seem to me like Minecraft is just a lot of just way more open world. And I could imagine something in between Crafter and Minecraft that might allow for tasks with tasks where you can't just like hard code a reward. But I haven't yet seen an environment where I really felt like that was true.
Yeah, makes sense. Thanks.
Cool. I might go back to one of my pre-listed questions. Yeah, were there any approaches you considered but didn't have time to implement? Some like pie in the sky ideas. Maybe you want to keep them for yourselves for next year, but ones that you're happy to give away to other people, perhaps.
Well, there was one that we were working on. We spent a long time doing this and it ended up not working, so we had to fall back. But we were in our method, right? We use behavioral cloning for learn subtasks, but we really didn't want to use behavioral cloning because behavioral cloning, we just know it's terrible, and that was always like the back plan C kind of thing. But we really wanted to do something just a little more advanced. We're going to use Gale, right? The generative adversarial imitation learning, because we just felt that would have been at least have a better chance than just regular standard behavioral cloning. I think I hadn't used Gale too much in the past. Most of Gale has been done on simplified environments, and of course, everybody I've worked with that has worked with GANs are like, oh, GANs are really hard to stabilize, and I'm just like, whatever. But now I'm getting my first, actual experience of, yeah, GANs are hard to stabilize, and just couldn't get Gale to work at all, and like up till last minute we were working, and then we just fell back to the just normal behavioral cloning.
Yeah, I think I've had similar experiences in the past year or two. Well, past 2 years.
Yeah, I would say like I had a similar experience working with Gale. So I was trying to, I was doing some research or internship at like Apple or something where I was like trying to make it work on productionized levels and just like hard to make Gale scale kind of thing. And I think like that's why we literally came up with like the IP learning work. Pretty much, it's supposed to, I guess, like solve some of the issues with that.
Yeah, that's interesting.
Yeah, and in the beginning, we also considered some flavor of inverse reinforcement learning. And one of the things we considered were AIRL and Gale. But yeah, I guess I'm glad we didn't go down the road. In terms of further stuff that we could try, so I don't think we used any like recurrency in our models currently. So I guess in that sense, I'm surprised that it worked that well as they do. So that's like an easy thing to do for next time. And of course, actually using the feedback.
I think one thing that I've been like quite interested in thinking about is that I feel that we could make a lot of use out of some sort of like transfer learning or meta learning of the policies, or like rather, so for example, with MineRL, you have a lot of different environments where you could just like train the agents to do well in some of those like environments which already have reward signals, and then you just try and like transfer that learning over into the BASALT tasks, because I feel like learning everything from scratch within the context of BASALT is possibly making things a bit harder than we need to. And that's, yeah, it's just one of the ideas that's been kicking around in the back of my mind that I would love to try out if like, yeah, in another iteration, for example.
Yeah, that does sound really cool.
This is quite general, but I really would like to try out a bunch of different ways of learning from human feedback. Yeah, our approach didn't, mostly because it just took so long to figure out the environment, and tried a bunch of things that didn't work. And so, yeah, if this goes next year, then exploring some of the human feedback elements would be really cool.
I've been looking for a different project, looking into vector quantized planning models, or like generally discrete models, stuff like VQVAEs, but also just the discrete models from Dreamer. And they seem to be doing really well, even in like complex environments like the DeepMind maze. But so far I haven't, so I'd actually tried to reproduce what they did with like their vector quantized planning model, because they didn't release any code, and I just couldn't get it to work for this other Minecraft project. But that might be something to look into for the future, because that could actually improve, I guess, like sample efficiency a lot if you have a working model. And then you can also, I guess, learn from offline demonstrations much more. Like you could basically just train it offline. And then that should make your online learning experience much more efficient.
Yeah. Yeah, the Dreamer set of, have there been papers about using things like Dreamer for tasks without rewards?
Not that I know of.
Okay, so you're imagining generalizing it to that setting.
Yeah. But I guess you could still at least keep the planning part where you just try to predict the next latent state.
Yeah.
I guess the thing you're facing then is that you will keep irrelevant information that's like not relevant for your reward. But you know,
yeah,
really seems better.
Cool. I think with that we can wrap up this breakout set. Well, both this panel and the breakout session. Thank you everyone for coming. It was great to have you here, and yeah, enjoy the rest of your conference. Bye.
Bye. Thanks.
Thank you. Bye-bye.
Thank you guys. Take care.
Okay.